So now we will do the workshop review. I will show you how you can take advantage of the flashing tools that we have inside WaterGEMS. So we already have here a model that was already built with the data that is required. We can see flow. Okay, so flow comes from two different sources. From reservoir number 2, water is pumped into the system, and also water comes from reservoir 1, and then water is pumped into the system. Okay. Basically, what we want to see now is to try to flush all the hydrants that we have already in this network. So you can see here the hydrants already defined, represented by this symbol. Okay, we will simulate flush all these hydrants and try to understand what will be the maximum velocities in each pipe, what will be the maximum shear stress in each pipe, and also what will be the pipes that will be flushed by each hydrant. Okay, so we go to flushing. In the flushing study, we have to define the scenario that we want to be included, and then in the base flushing options, we define what is our target velocity. We will define 0.9. Okay, we also have to define then the pipes that we want to flush. In this case, we want to include all pipes. Okay, because we are going to flush all hydrants, so we want to have results for all pipes. So here I select all pipes. Okay, and then we have to define a flushing flow. Okay, it can be by setting an emitter coefficient or by setting a demand on the hydrants. Okay, what are the main differences? If we specify a demand on the hydrant, this means that the flow will remain the same regardless the pressure in your system. Okay, if in other end, if we define an emitter coefficient, we are going to define that the flow flushed by the hydrant will change depending on the pressure that we have in the network. Okay, so let's change here the emitter coefficient. And let's put, for example, a value here of 12. Okay. Okay. Here below, we define which results we want to see and what are the nodes and the pipes that will be included in the results. And now compute. Okay, so before computing, you will see a message that says there are no flushing events. Okay, so before starting compute, you have to define which the events that you want to run, right? To compute, and we have two different options. Okay, so we have you can run conventional flushing events or unidirectional flushing events. What's the main difference? The conventional flushing events, it's normal flushing events. You just go to the network and you just open the hydrant and you take flow from the hydrant to understand what will be the velocities and shear stress inside the pipes. Okay. The unidirectional event is when you want to close some valves in order to force the flow in one direction in order to increase the velocity in the pipe when you are going to open the hydrant. Okay, that's the main difference. For now, let's start with the conventional events. You add new conventional events, then you have to define which hydrants you want to flush. In this case, I will set for all hydrants. Okay, and then you will see an event per each hydrant. Okay, so for each event that represents an hydrant that is going to be flushed, I have here the element itself. So what's the element, the type, so it's an hydrant. We can also, if you don't have hydrants in your model, we can simulate these hydrants as a node. Okay, so we can have the nodes working as an hydrant. And then the emitter coefficient that we defined in the general options. Okay, we can override some specific constraints at a specific hydrant. So for example, here in hydrant, imagine 171, if you want to specify another emitter coefficient, you can do that. So for example, here you can put, for example, 30, okay, or specify another flow. Okay. So after doing this, we just run the events that we have here defined, compute inside the flushing analysis tool. Okay, automatically a new scenario will be exported to the model called flushing output base flushing, because we call this base flushing, and all the results will be in this new scenario. Okay, so let's compute this new scenario. This new scenario will be able to see, for example, what will be the velocities or the shear stress in the pipes when we flush the hydrants. So for example, we have here a field for maximum flushing. Okay, in this case we will see, let me open the legend. In this case, we will see what will be the velocities in all the pipes, the maximum velocities in the pipes when we flush the hydrants. So there are pipes with very good velocities, very high velocities. There are some pipes where we cannot achieve very high velocities. So, for example, the green pipes that corresponds mainly to extremities of the network, the velocities are below 0.3. So these are the main results. We can also see these results, for example, in a table. So if you go to flushing area report, we will have for each hydrant that was flushed, what was the length of pipe that was cleaned and the maximum velocity achieved. Okay, so and if this satisfies or not the flushing target velocity that we set it for 0.9. Okay, we can also see maximum shear maximum stress. Okay, we can also see, for example, the pipes that are not achieving the minimum target velocity defined, that was 0.9. Another way to see results, we can go to the browser, for example. Okay, we can set velocity to be checked on the map and the demand at the hydrant. Okay, and once we click on a specific row here, we are selecting a specific flushing event. So in this case, it means that we are flushing hydrant number 6, that this is one. And these are the velocities that are achieved when we open this hydrant. Okay, and we can go and we can continue with this. So now we are flushing hydrant number 7 is this one, and we can see the maximum velocities in all the pipes in the network when we open this hydrant. Okay, of course, the main velocities are achieved near the pipe that we are near the hydrant that we in the pipes near the hydrant that we are flushing, right? So that's the expected result. So after this, let's simulate a unidirectional flushing event. Okay, so remember, an unidirectional flushing event, we will set some valves to be closed while we are flushing an hydrant in order to try to increase the velocities in those pipes. Okay, so let's go again to the flushing tool. We have to create a new area. Okay, we will call this unidirectional flushing event. Okay, the same as before, we have to set the scenario. In this case, we will take advantage of the conventional flushing that we already ran. And the target velocity will be the same, 0.9. We specify the pipes. Okay. And then the emitter coefficient, we will set the same value. Okay. After this, we add a new unidirectional event. Okay, where we have to define which hydrant we want to flush and which valves we want to close. Okay, so the hydrant that we want to flush will be, for example, this hydrant number 42, and the valves that we want to close in order to increase velocities when this hydrant will be opened will be the valves 212 and 85. Okay. Here, the valves that will be closed and the hydrant that will be flushed will appear. Then just need to click compute. Okay, again, as the previous run, once you compute this in the flushing tool, a new scenario with the results of the unidirectional flush event will be created. Okay, so this new scenario is called flushing output unidirectional flow event. And we can see now what will be the velocities, just assuming that we are going to flush hydrant number 42. Okay, so these will be the new velocities when we close these valves and we flush this hydrant. Okay, as expected, the pipes near the hydrant that is flushed will have higher velocities. Okay, you can see, for example, the maximum velocity is also in the property menu in this section of the results flushing study. Okay, so in this case 0.8. Okay. We also can see a report and print a report, a PDF report. So if you go to the flushing tool, you see that the event, and then there is here flushing field report. A PDF report will be generated, exactly defining which hydrant you have to flush, which valves you have to close, and also a table for you to insert with the times.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.